Okay, so today we're going to talk about automatic scaling and monitoring. Okay, in other words, automatic scaling is auto scaling. It's another way to call this service in AWS, which, by the way, is a free service. All right, you don't pay for it. You just pay for the resources that you create with auto scaling. Okay. Now the topic is elastic load balancing, Amazon CloudWatch, Amazon EC2 auto scaling, activity elastic. I'm sorry about that. Elastic load balancing activity, Amazon CloudWatch activity, and then we're gonna have the lab is already open. All the labs are open. Scale and load balance your architecture. Okay, and the knowledge check. So after completing this module, you should be able to indicate how to distribute traffic across Amazon Elastic Compute Cloud, Amazon EC2 instances by using elastic load balancing, identify how Amazon CloudWatch enables you to monitor AWS resource and applications in real time, and explain how Amazon EC2 auto scaling launches and releases servers in response to workload changes. Perform scaling and load balancing tests to improve an architecture. Now, elastic load balancing. Guys, there are three types of elastic load balancers in AWS. One is the application that works on the layer 7 of the OSI model, right, which is the application layer. And the other one works on the network elastic load balancer works on the layer 4, which is the transport layer, right? And the other one is the classic elastic load balancer, which is a combination of the two that works both on the 7 layer, the layer 7 application layer, and the transport layer, which is layer 4. Okay, sometimes the people use that, but Amazon just separated them in independent elastic load balancer. All right. This guy is the elastic cup, the traffic cup that distributes the traffic to different EC2 instances or containers or Lambda functions or whatever servers or things like work like a server like Lambda is going to be distributing the traffic all along the way. Okay, so it is distributed traffic to targets. That's what they call for they're called targets. So they just target specific resources and they distribute traffic to those targets. Elastic Load Balancer has something called health checks. So it will be constantly, checking the health of the resources. It's like, give me a heartbeat and I will respond to you, right? I will send you traffic as long as I know that you are alive, right? You are functioning. If you're not functioning, so I will stop sending traffic to you, okay? Distribute traffic application and network traffic across multiple targets in a single availability zone or across multiple availability zones. So if you are trying to send traffic across multiple availability zones, then you will have to have something called cross-zone elastic load balancer. So you have to enable that for the elastic load balancer to be able to, distribute traffic across availability zones, okay? It will scale your load balancer as traffic, right? And to your application changes over time. He's going to be working, elastic load balancer is going to be working in conjunction with auto scaling, right? That's going to be synchronized and working, right? So there's going to be health checks in both in auto scaling and elastic load balancer. And then they're going to be working in conjunction, like I said before. If the EC2 becomes, unhealthy, then it will create one for you guys, right? So that's elastic load balancer. Types of elastic load balancer, we have the application one, we have the network load balancer, and we have the classic, which is the previous generation. But AWS decided to have an independent one called application and then network, right? This guy works with the application layer that has the traffic in the HTTP, HTTPS, right? This one works with TCP and UDP, transmission control protocol and user diagram protocol. Those are protocols for traffic transfer. Remember, it's layer 4, right? And TLS, which is a secure way to transfer traffic, right, from one place to the other in a secure way. Okay, this is a new generation of SSL, right, which is secure socket layer. This is for extreme performance. When there's a heavy duty of a lot of millions of requests, this is the guy. So in your exam, which is going to be either today, tomorrow, or Sunday, or maybe Monday, and there's some people that are going to leave later than that. Whenever you see that the company is looking to implement an elastic load balancer that can handle millions of requests per second, this is the guy, network's load balancer. Don't forget that, guys. That's very important. Okay. And if it is HTTP and HTTPS, that's the application load balancer. Okay. So there are keywords here that you shouldn't forget: the HTTP, HTTPS, TCP, and UDP. And also this guy will be the combination of both of them. Okay. Now this guy will route the traffic to targets based on content of request. This one will route the traffic to target based on the IP protocol data. Okay. Either TCP or UDP, and also TLS. Okay. It's based on that. And this is based on the content of the request. This one will provide advanced request routing targeted at the delivery of modern application architecture, including microservices and containers. So this is a tough guy as well. Okay? This also has forwarding, port forwarding, so you can forward the traffic to a different port. Okay. This one can handle millions of requests per second while maintaining ultra low latency. So as you can see, when it comes to speed and load, this is the guy. Okay, it's ultra low. It's not low, it's ultra low. Okay. And this one can load balancing across multiple EC2 instances. Okay, this is the classic one. Okay. Now this one will work on the seventh layer, this one on the 4th layer, and this one in both layers. Okay. So keywords here, guys, don't forget keywords: HTTP, HTTPS, application load balancer, TCP, UDP, TLS, network load balancer, both classic load balancer. This one will route the traffic to target based on content or request. This one based on IP protocol data. This one can handle millions of requests per second. And this one will just provide advanced request routing targeted at the delivery of modern application architectures. Okay? So when you hear the word application, it's most likely this guy. When you hear the word network, it's most likely this guy. Okay? Layer 7, this guy. Layer 4, this guy. Both layers, this guy. Okay. Don't forget that, guys. That's very important. Make this chart your friend before the exam. Okay. And try to remember this because they're going to ask you the exam.
Like W.
So how elastic load balancing works? With application load balancers and network load balancers, you register the targets in target groups, right? And route the traffic to the target groups, right? That's with the application. That's what the application and network load balancer. With the classic load balancer, you register instances with the load balancer, not with the groups. Okay? So you don't need to use target groups with the classic load balancer. With the other two, yes, you need that. Okay? Now, load balancer performs health checks to monitor health of registered targets. That's what I said, guys. It will be checking, your status to see if you're healthy or unhealthy all the time. Okay? So we have here an AWS cloud, right? And then we have 3 users here, right? And then they are, sending traffic to this availability zones, right? Now, the load balancer accesses incoming traffic from clients. So this is something important, guys. The concept behind all this idea of the elastic load balancer is to have a single point of entry. You don't want people to access your EC2 instance directly, right? You want people to come through the elastic load balancer that has security in place, and then through the elastic load balancer, then you can access the target, okay? A single point of entry. That's what we are shooting for. Okay, we're aiming at this, having a single point of entry, right? Okay. So we have here availability zone A and availability zone B, and then we have a listener here. A listener, correct? It's listening on port 80 or port 8080 or port 443, depending on what port it's listening to or listening on. And then we have another listener here, right? So listener checks for connection requests, okay? Make sure that, the listener is checks for connection request. And then we have the connection with this target, but we don't have a connection with this one. Okay, so this one is not connected. Now, as it is not connected, this listener or this elastic load balancer will not send traffic to this target because it's not connected, right? And how does it know that it's not connected? By simply sending a head check. Check the health of this target every now and then, right? And if there's no, sign that or signal that there's some sound or anything that it cannot listen to it because it's not healthy, then it will stop sending traffic to this guy. And, when autoscaling creates another one, then it will start sending traffic to the one that was just created. Okay. Here we have a listener, and it's checking, and everything is fine, right? So it's going to check this. It's check. It means that it's operational. Then we send traffic to this elastic, to these targets right here. All right. So that's how elastic load balancer works. We're going to check that the target is healthy, and then we start sending traffic to that target. If it is not healthy, then we stop sending traffic until another target is created. Okay? So that's how elastic load balancing works. Now, the use cases here, it's highly available on fault-tolerant applications. Okay? So it will stay there. It will not be down. Elastic load balancing is not down. It's highly available. And it's capable of still being operational despite disasters and despite, events in life, right? It can work with containerized applications. It doesn't only work with EC2 instances. It also works with containers. Okay. It also is elastic and scalable, right? So you may have more. You may need to have, be able to scale other across multiple availability zones. So you will scale up, scale out and create, be able to cope with all the traffic, right? And it's elastic. That's why you call it elastic load balancer, because it can, support multiple and a great number of EC2 instances, right? You can use it in the virtual private cloud. That's the case that we have here. It's inside a VPC, right? Also, you can use it in a hybrid environment. When you have, part of your resources are in the cloud and part of your resources are on premises, still you can use the elastic load balancer. And you can use elastic load balancers with Lambda. Lambda functions over HTTP or HTTPS. Remember that the application load balancer can work with HTTP and HTTPS. Okay. These are six of the examples. Some of the six of some of the examples that you can use Elastic Load Balancer with. So, activity here, Elastic Load Balancing, you must support traffic to a containerized application, and the answer is, I guess you know the answer already, guys. What is the answer here? What's the load balancer that supports containerized applications?
Network.
What is it?
Network.
Network.
Are you sure?
This is what a container application. It's not ESP. I think I will put it.
Application load balancer. Okay. You have extremely spiky and unpredictable TCP traffic. What is it?
TCP is network.
Network, for sure.
Network. You need simple load balancing and multiple protocols.
Network.
Simple.
Classic.
Class.
Remember that Classic also has multiple protocols. It has TCP, UDP, TLS, right? It has both. You need to support a static IP or elastic IP address or IP target outside your VPC.
Network.
Network.
You need a local balancer that can handle millions of requests per second while maintaining low latencies.
Network.
Network. Guys, again, when you hear millions of requests per second, that's the elastic load balancer. Okay. You must support HTTPS request. HTTPS, HTTP.
Application.
Application load balancer. Okay. So guys, if you can take a picture of this in your computer, right? Remember this, right? This is some of the use cases of the elastic load balancers. Okay. Load balancer monitoring. We have this guy called Amazon CloudWatch, right? That we can use for our application, right? So we can go here and then, okay. And then we have this guy who is the guy that we use for automation, for monitoring of resources, right? And, and things that you can just for alarms, rules, okay? Cron jobs, right? Cron jobs, event patterns, right? You have the service name, event type here. It depends. Let's say CoStar. And then you have all the API calls via TriCrail. And then you can have here, an event source, a rule. And then you can put a target here, whatever you want to put here. If it is a Lambda function, whatever type of, service you have here. So this is one of the, I cannot emphasize it more than this. This is one of the toughest guys. When I say tough, I say one of the most important resources in AWS, CloudWatch. I have taken several certification. I have the Cloud Practitioner, I have the SysOps Administrator, I have the Developer, I have the Solutions Architect, I have the DevOps Professional, right? I have studied AWS like crazy, and I always see CloudWatch. in every single certification. I always see S3 in every single certification. I always see EC2 in every single certification. I always see DynamoDB. I always see Lambda. I always see EBS. I always see EFS. There is resources that are always there. Some services that they're not gonna go anywhere. They're gonna stay with you forever. Forever, guys. If you're planning to continue the cloud, you're gonna see these guys all the time, but in a different level, more profoundly. Okay. For this certification is just, superficial. When you get to other certifications that are more advanced, you're gonna know another phase of CloudWatch that you don't know with Cloud Practitioner. Okay? So that guy is gonna be there forever. Okay. So the metrics, let me see if I have an EC2 instance here. I don't have an EC2 instance here, but you can see per metric, right? By auto scaling group, a lot of, you can see how your EC2 instance is performing. Okay, let me create an EC2 instance real quick. All right, I don't have any running right now, so I'm gonna create one real quick. What is this? Error loading data? Is there any problem right now with AWS? Any problem right now? Oh, you said there were some network connectivity issues, but it says resolved. Okay.
One for you. An answer, we're getting fine.
Connectivity issues for a small subset of newly launched EC2 instances within a single availability zone in the US East, one region. So that's where we are right now. That's where we are right now. That's why it's not showing anything here. Oh, now it shows it. Okay, not a problem. It's good to know that. Okay, so let me heal that. Do you have any problem logging in?
I did. I had the first time that I had to actually put a password in, but that's okay. Never mind.
Okay. So let me create just this guy real quick. I don't need to go through all this. I don't need any of this. So I'm going to launch it, and I don't even need a key for this. I'm not SSHing into the EC2 instance. So I prefer to proceed without a key. So I don't need that. So let us wait for that instance to launch and then send some metrics. Okay. So we're going to be able to see something here in the monitoring section here, right? And these are some of the metrics: CPU utilization, status check fail account, network in, network out in bytes, network packets in count, network packets out count, disk reads, disk read operations, disk writes operations, CPU credit usage, and CPU credit balance. Okay, so these are some of the things that you can see for your EC2 instance. Now you can see it every hour, every 3 hours, every 12 hours, every 1 day, 3 day, 1 week, and you customize it probably every 3 months if you want.
Question, Professor.
Go ahead.
I remember CloudTrail, you mentioned the data is saved in S3. Is the same for CloudWatch?
CloudTrail?
The data.
CloudTrail?
Yeah, CloudTrail, I remember you told us the data is saved in S3 buckets.
Mm-hmm.
In CloudWatch is the same or no? The data?
No, CloudWatch is just to give you an idea of the health of your services.
So if I want to know about the history, where is the data saved?
The history
Yeah.
You may see the logs here. There's one
Yeah, the
section.
logs. Yes, the logs.
If you go here to CloudWatch, monitoring here to dashboard, and then you want to see this in the dashboard, and I'm gonna call it, just let me add it, create a new CloudWatch, call it new dashboard. All right. And then I just add the dashboard, and I will see this in a very much better place. Okay. Now, if I come here and I click on the logs, right, I can create a log group and give it a name, right?
Right.
And then just give it a retention of 7 days, for example, maybe more. Right? And then I can have these services here. These are the log groups. They're created by AWS. So now I can create a log stream, and give it a name. They change the interface. Every time they change this, they just, you see how it says change to the new experience and the old interface. So here in the insights, they can even use here SQL here. But let me see here. The EC2 instance here. So I have the dashboard here. And then I can have metrics. EC2. This EC2 per instance metric. This one. Where's my instance? Where's my instance? Did it update already? So it's running, right? It's running. Monitoring is here. We're going back to the same thing. CloudWatch logs. Okay. I already created a log group. Okay, do you want me to create a log group? These are the log groups that I have. Okay. So these are the ones that are created when I created my React tab, things like that. You see, they are created by default. Okay. I already did this. Okay. So, okay, so for that, now that I remember, you have to install the CloudWatch agent. Okay? When you install the CloudWatch agent on your EC2 instance, then your EC2 instance will send the logs to CloudWatch. Otherwise, you would not have any logs of your computer.
Cruising Power Help Desk, how can we assist you?
It's like, who was the one that asked me?
Ruben.
Ruben. Yeah, let me mute Leslie. All right, Ruben. You know, when you have a computer and there are actions that take place in your computer, there's one file that is usually in the var folder in your system, var, and then you find the logs in that folder.
Yes, I can get you through to your reservations if you want to get it reinstated. Is this for Royal or Celebrity?
I don't know why I muted her, and she's back on mute.
One moment, please.
Okay. So in your computer, if you're able to do at least with Linux and Unix systems, there's one. Let me show you here. One moment. So this is a Linux machine. Okay.
I created the same.
Okay. So I'm here in Ubuntu. Right now, if I do cat, let me do cd var. So I'm inside the var file, and I have a folder named log, right? Then I'm inside that folder, and I have a bunch of files here, which are the logs of the system. You know, when it has to do with authorization, authentication, system log, all these folders here, right? So your computer automatically is logging all this, you know, operations that are done in your computer, right? So your EC2 instance doesn't have that capability until you install the agent, the CloudWatch agent. So your EC2 instance, you just create it. It doesn't have anything inside. It doesn't have any files. It doesn't have anything. You have to install the CloudWatch agent so that agent can start sending logs of every single operation of your EC2 instance to CloudWatch. Okay, so it's right here. You have to install the CloudWatch agent using the command line. So you can SSH into that particular EC2, and then just put this guy there. Okay, and that guy is going to be sending, you know, logs to CloudWatch. Okay, so the CloudWatch agent is available as a package in Amazon Linux 2. This is the package manager, Yum, which is a CentOS, the Red Hat package manager. If you have Ubuntu, then we cannot use Yum. In this case, I will have to use this guy. I will have to use this guy, APT, right? If I say Yum here, it would not recognize it. It just gives me a red color because it doesn't exist. Yum is for CentOS, for Red Hat. This is for Debian. Ubuntu is Debian. That's why I use APT. So with APT, I can just say uninstall whatever I want. Just whatever I want here. Okay. Same thing here. We're just installing Amazon CloudWatch agent with this package manager. Okay. So you can install the package by entering the following command. You must also make sure that the IAM role attached to the instance has the CloudWatch agent server policy. Okay. So whenever you create, right? So I'm going to create an EC2 instance real quick, right? So I'm going to create an EC2 instance, but I can use this EC2 instance. What I have to do is just, you know, just edit the port 22. Just come here and find the security group that I created, right? By the way, it has 82, but I didn't choose any key, right? So let me see if I can use that key. Okay, let me copy this guy and let me come to my terminal here, right? Right? Okay, and let me do this. Let me do this. Okay, SSH. Let me make this bigger. Okay, so I'm gonna do SSH I, and then I'm gonna change this guy here to see if it lets me log in with this. All right. No, because I didn't choose the key when I created this instance. Let me create it real quick. Let me just terminate this one because I don't want it to be running here. So I'm going to terminate it. Okay. And I'm going to launch a new one real quick. I'm going to come here, and I think that by default it has port 22 open, right? So I just let me just do it like that. Okay. Wow. We have to create a role. Don't forget that, right? So now I'm going to create a role, right? And then we're gonna find that role here, that policy that is attached to that role. Okay, so I'm gonna copy this, and it doesn't show anything. Okay, CloudWatch. I know what you mean. Okay, you see, find the policy here. It's right there. Okay. So what I have to do is create a role, right? And I'm gonna put here CloudWatch. Okay, I'm gonna create here EC2. And I'm gonna put this guy here. And now we do this. We do the tagging, we don't need that. I'm gonna call it my CloudWatch log role. Dunieski, right? Just to differentiate it, right? And then I create the role. Right? Fine, perfect. Now I come here, I just refresh this, and then I see my CloudWatch right here. Perfect. So I have that role there that's going to allow my EC2 instance to interact with CloudWatch. Okay. So I just come here, add, just configure security groups. Now this is by default this one, so I don't need to do that to just do anything else. I'm going to create, just use this key here and launch it. Okay. So now I'm going to take a look at that guy, and let's wait for that to just change the status to running. And I'm going to grab this IP address, and I'm going to be ready for that. Okay. So I'm going to wait for that to do that. I'm going to do this, change the IP address, and wait for that to start running so I can SSH into that instance. Okay. So I can have guide from AWS, right? I can have guide. This is very important, right? So now I take a look again, it's running already. So I can come here and say this. Yes. And it's giving me the same error again. Assure you want to can be established. Fingerprints, as I said. Permission added, permission denied. So do you mean that oh, I know why. Because it's in my desktop. Okay, now it's gonna say yes, perfect. Okay, you have to do it where the key is. Okay, so now I can copy this guy, but instead of using yum, or actually I can use yum. Okay, let me use yum here. Okay, I need to be the root. Okay, I'm the root now. Okay. Good, install CloudWatch agent. Now, it's a pity, guys, that I'm doing this the last day of the class, so I cannot show you what's going on after a while, okay? But once this is done, okay, now the EC2 instance is going to start sending logs to this. So whatever I do, right, whatever I do here, if I want to just do yum y update, okay, so let's data things here. Right. So that CloudWatch agent enables you to do the following: collect more system-level metrics for Amazon EC2 instances across operating systems. The metrics can include in-guest metrics, in addition to the metrics for the EC2 instances. The additional metrics that can be collected are listed in metrics collected by the CloudWatch agent. Collect system-level metrics from the on-premise servers. Retrieve custom metrics from the applications. Collect logs from Amazon EC2 instances on on-premise servers, running either Linux or Windows servers. So all the things that you can do when you install that guide. So now I can say, for example, touch, just touch test file, txt, right? I created a touch. I can say echo. I'm testing. Let me clear the screen. Right? I can say echo. I can say echo. I am just testing this file, right? And I've redirected to test at txt. Okay? Now if I do, I see cat test .txt, I see that I have that file. Okay, perfect. Now I can do cat.txt, a test.txt, and I can say new test.txt. Okay, now if I say cat new test.txt, now I have the same test. Okay, and when I do ls, I have two files there. Now I can do remove, just removed all the tests that have all the files that have txt extension, and then yes, and then yes, and then it says ls is gone. Okay, nothing's there. Okay, after a while, I will be able to see, if I just go to CloudWatch, I will be able to see some more metrics on that guy. Okay. Okay. No, these are alarms. I'm not alarms. Maybe logs. Oops. Mm, metrics. Okay. Okay. Just let me do something real quick here, and let me just give it a name and say new server. Okay. And now let me just come here, and then what's going on here? It's so unstable. Okay. So utilization. Metric, this one. Okay, 5 minutes average. Okay. We will have to wait a little bit because it takes time, right? It takes time for the metrics to kick in. Okay. I just installed it. Okay. Okay. So maybe by the end of the class we can take a look at it again, right? And understand that. But we did what we're supposed to do. We have the role. We have our CloudWatch agent installed. So now what you have to do is just wait, and it will collect those metrics. Okay. We can do that. And when we have that, you can store those metrics in S3 buckets. Okay. So let's continue with the class because we have to finish this. Okay. But that's what you do. Okay. So we verify that the system is performing as expected and creates an alarm to initiate an action if a metric goes outside an acceptable range. Okay? Access logs capture detailed information about requests sent to the load balancer. So the load balancer has something called access logs. So if you come here to Elastic Load Balancer, Elastic Load Balancer, Load Balancer. Oh, sorry about that. It's here in the EC2 dashboard, right here. So we create a load balancer. We can create either an application. Let's just create a classic for one for now. Okay. So when you create an Elastic Load Balancer, you can make it an internal Elastic Load Balancer, an internal one. I don't want to get into this because this is more for the solutions architect, but you can have internal load balancer and internet facing load balancers. Okay. So I can give it a name, just my Elastic Load Balancer, my ELB, right? We're going to have it in this default VPC, right? It's not going to be internal. It's not going to have advanced VPC configurations. And the listening configuration is going to be listening on port 80, right? Now we come here to the security group. We may use a security group that has 80 port 80 open. Let me see if I have port 80 here. Show me. You can show me. Show me here. Let me create one. Okay. So port 80. Okay. And then let's just have port 80. It's just there. Okay. So that's how port 80. We continue to the head checks. Okay. We're gonna be checking for this file. Okay, because it's gonna be a web application or website. right? So we're gonna response time. This is a time to wait when receiving a response from the health check. So 5 seconds. I'm gonna wait 5 seconds, okay, until you give me a response that you are working. So this is the amount of time between health checks. In this case, we have 30 seconds, right? And the minimum is 5. We don't have 4, right? 4 doesn't exist. And here we have to have 5, okay? And the maximum is 300, right? Which is 5 minutes. Is it what it is? 5 minutes, right? 5 minutes. And we can have 305. That is incorrect. So 300, right? This one is number of consecutive health checks failures before declaring an EC2 instance unhealthy. We're gonna try 2 times. Okay, we can try up to 10 times here, right? But we're gonna try 2 times, 3 times. If after 3 times I don't receive response, then I consider you unhealthy, and elastic auto scaling would just eliminate that. Number of consecutive health check successes before declaring an EC2 healthy. Okay, so I'm gonna add the EC2 instances. I have this one right now, right? I'm gonna do tagging, right? Create, review, and create. All right. So the last load balancer, the classic one, doesn't have the access logs. Okay, but if we do this one, right? Now my application, ELB. It can be internet facing or internal. I want it for internet facing. That's why it's going to be listening on port 80. Okay. One subnet must be specified. Let's go back. Okay. Oh, I didn't see the other part. Okay. We're going to use the default one. Okay. Because this one doesn't have any subnet. Okay. This one has 1, but let me choose this one. So we're going to put it in East 1, right? And East B2. Okay. Good. So now we go here and it's secure listener because it's not using 443, it's using 80. That's not secure. So now we're gonna use port 80. It's right here, right? And now we can have some more settings here. Okay. New target group. Okay, I'm gonna create a target group. My EC2 target group. Instance. The target type is gonna be an instance, not IP or Lambda function. It's gonna be an instance. Port 80. The path, the same thing here. Now we're gonna register the targets. I'm gonna select this one, add to register. This one is registered already and it's running. Now I can do review, right? And then I can do create. Okay, so now I close. And I have 2 elastic load balancers here. Okay. So I have these guys here. I have the instances here, right? I have the health check. I have the listener. I have the monitoring here, CloudWatch. Okay. Now I don't have any tags. I don't have any migration here. Okay. I have these guys here, right? I have the listener. I have the monitoring, integrated services. I can integrate the global accelerator. That's another service to get a static IP addresses that act as a global fixed entry to your load balancers in a single or multiple AWS regions. And I have tags. Okay. As you can see, the application one takes more time to create, right? And then you have to wait until it's provisioned. Okay, so that's how you create the glass load balancers. Still provisioning. You see here, access locks, right? So now I can choose any bucket. In this case, I think I have to take a look at my bucket. Okay, so I have to come here and just let me choose this again, and then access logs enable, and come here to my EC2, my S3 bucket, right? And my S3 bucket, let me take a look at one of bucket for login Dunieski, right? So I'm gonna copy this name, right? And I'm gonna put it here, right? And I'm gonna save it. Okay, please check the bucket permission. Okay, so I have to make probably this bucket public. Guys, remember that I created the access logs for this, remember? Remember I did it on Wednesday?
Yeah.
Look at the logs here. These are the logs. So we have to create a policy, a bucket policy that allows this guy, okay, to exist, to be able to work on this. The bucket permission is not, allowed to do that. Okay. So there has to be a bucket policy in the bucket so that you can allow this this guy to be able to log everything in the S3 bucket. But at least, guys, you know how you can do the access logs here. All right. And that's what we're talking about here. It captures detailed information about requests sent to the load balancer. So every single IP that comes, right? Every single IP that is rejected is going to be logged in the access logs. Okay, that's a way to troubleshoot things that happen in the network and the last load balancer, right? AWS CloudTrail logs. This is the other guy that is used for governance, auditing, and compliance, right? It captures the who, what, when, and where of the API interaction in AWS services. Okay, we know about that already. So this is a takeaway here. Elastic load balancing distributes incoming application and network traffic across multiple targets in one or more availability zones. Elastic load balancing supports 3 types of load balancers: application, network, and classic. Okay. And the ALB, Elastic Load Balancer, offers instance health checks, security, and monitoring. Okay, so if we take a look at this, right, we have monitoring. Okay, if we take a look at the description, we have health checks. They're here. Head checks here. Okay. So the classic one has head checks here. This one has head checks too, right? But they both have that. Okay. Yeah, when you make it work with Elastic Load Balancer is when the health checks work in conjunction with that. Okay, so now I can see this guy here. Oh, you see, who was the one that asked me before? Who was the person that asked me about the logs? Who was that?
Hey, Ruben.
Ruben, you see now? You see, before we didn't have anything, right?
Right.
You see, now we have metrics here. Okay, so we start having metrics here.
That means they are saving the log.
Yeah. At least we have, we have information here. Okay, this is to query the log group. Okay, I'm not going to stop with this anymore because I will not be able to do not what I want to do. Okay, so CloudWatch. We have CloudWatch here. Now monitoring AWS resources, right? To use AWS efficiently, you need insight into AWS resources. How do you know when you should launch more instances? Is your application performance or availability being affected by a lack of sufficient capacity? How much of your infrastructure is actually being used? Those are the questions that you should ask someone when trying to, architect in AWS. Now, what does AWS CloudWatch does? What does it do? It monitors AWS resources, application that runs on AWS. Every single resource is monitored by a CloudWatch. Also, you have to understand that there are two different ways it presents itself. It's basic CloudWatch and enhanced CloudWatch. Okay. Also, the standard metrics are the ones that I already showed you guys. And there are custom metrics that guys you have to, have to find. All right. Now let me do something here. Let me see something here. This is something here. It hasn't seen any logs yet, but this is where Ruben, this is where you see the logs. Okay, but there's no logs here. Probably is, because nothing major has happened in the EC2 instance. Okay, this is where you see the logs in this file here. Okay. The CloudWatch agent was installed. Okay. So it was installed by us, right? And the role was added. Okay. Okay, let me do something here. And then I can do this. This is the way that it is. That's not correct. That's what it is. Okay. Now we should have something here. Okay. If we move to var, right, and then we do ls, we have log, right? So we can do cd log, right? We do ls, we should have AWS logs, okay? And then we can cat AWS logs, and then we have these guys here, okay? So we have missing value. We have these guys here, right? Number of events, types, okay? Okay, maybe, okay, so probably if we do we do head N1, and then we put the name of the file, which is AWS logs, and then we get, is it clear here? Clear. We save this. We get the first line. Missing a value for this content, coding, defaulting to use, and coding. So now we're getting that. We can do this for every single service and every single system of the EC2 instance. And then we're going to have logs soon. Okay. So this is just, this is just the documentation from AWS. Okay. AWS has documentation for everything, so you don't have to remember things like this. You just have to remember that there's a place that AWS has, right? Right. So everything is in this guy here. Okay. So we cd, and then we say cat, this guy, and then we get all these configuration files here. So following table documents, the detail the time format specification. Okay. This is for configuration of the logs to track. Okay. Okay. Ways to do that. And we have even more information here. We have even more information than before. So we're getting more information here. Var log messages, log stream, queue, publisher. Okay. So we can save this. We can send this to an S3 bucket, and the S3 bucket, we can use this service called Athena, and we can query the database, right? And with Athena, we can have a table in the form of a table, right? Bringing this information from, from an S3 bucket, and then we can have a table that is by columns, not this disaster here that is hard to read, right? But at least we're getting logs now, okay? And as we continue getting more and more, right?
Professor, is that a JSON file?
No, it's not a JSON file. It looks like it, but it's not a JSON file. This is just a log file.
Okay.
See, it doesn't have the JSON extension. It's just a log file that is in this folder here, name log. Okay. And then we have all this. And by the way, guys, I am inside the EC2 instance. Okay. So maybe if I cat messages, right? Messages. I have a lot of things here. You see, remember that yum AWS logs. Remember everything here? Guys, remember that I did this, right?
Yes.
I became a root, right? And then you see, starting to use a slice of root and remove slice of root, stopping use slice of root. And then here, store AWS Norc, stopping dynamically generate message of the day, starting AWS daemon, all the logs of the system, right? Why do I have all this? Because I installed the CloudWatch logs. So I do this again, and then I have all the message here that I can have, and then I just cat AWS logs again. And then I have more information than before. I have more. Okay. I have this before I had until this section here. Now I have more. Okay. So it continues to log and log and log, more and more and more and more. Okay. And this is the log group. Okay. I don't know if I just go to CloudWatch, see if I can find that guy here. Right. I go to CloudWatch here and say the log groups. And then if I do this, I find this guy, and then what is the instance that we're talking about? What is the instance? So let me see the instance here. Let me see the ID of that instance. That is the one ending in A9F1. A9F1. You see, guys? I have here log screens that I didn't have before. Beautiful. You see? So Ruben, do you see it now?
Yes, sir.
See the logs? Okay. And then you can expand that and see more. Okay. Expand more. Expand more. Right? So that's the way CloudWatch agent does. Okay. Beautiful. Beautiful. Okay. So we continue here. We can send alarms to an Amazon SNS topic, perform Amazon EC2 auto scaling, or perform EC2 actions, events, perform rules to match changes in AWS environment, or route these events to one or more target functions or streams for processing. Guys, that is exactly what I did when I created the rule and I stopped the EC2 instance. Remember? With my Lambda function, that's what I did. I just got the target is Lambda function. So let me create a rule real quick for you guys to see it again. I create a rule. I just choose whatever I'm choosing here, just a jump crowd job, and I can choose the target here. That can be a Lambda function, or it can be any other service here in this list. Okay. I choose the target, and then I automate this process for me. Okay. Now, CloudWatch alarms. You create alarm based on the static threshold, anomaly detection, or metric math expression. Okay. So maybe I can come here and just create an alarm. Okay. Create an alarm and say select metric. Let me select, for example, maybe EC2, maybe. And maybe choose the metric and select. This is so annoying. Okay, it doesn't let me scroll up. It doesn't let me scroll up.
Professor, could I use CloudWatch in order to log my application? Like suppose I create a web API and I want to log the request or the sections.
Yeah.
Or are these just logs for the system?
You can have different logs for the system. If you can have for the system, you can have everything, even the API request, HTTP request, everything.
So everything, I mean, CloudWatch can help me with those logs, right?
Yes, but also you're going to have logs in the load balancer.
Okay, good.
Are you going to have logs in the VPC? So you have a lot of logs.
Thank you.
Right?
Thank you.
Or it even gets to the EC2 instance, you already have logs in the VPC and the load balancer. So basically, you don't need the EC2 logs when it comes to access from the web, because you already have from the other guys. Oh, let me see here. I cannot, guys, I cannot scroll up. I don't know why. This is not letting me grab this and move it up. I don't see anything below. I cannot see anything. I see now, but when I try to see now, I don't see anything. It doesn't let me see anything. So let's say usage by AWS resource. Okay, what do we have here? I don't have anything. It's not. Yeah, I want to check. I want to check CPU usage, but it doesn't let me. It doesn't let me check. So if I say EC2, then per instance metric, okay, it doesn't let me do anything. Whereas if I come here, right? If I come here and I check metrics, I can see it clearly, same thing. And then if I choose by metric, I can see here, here, right? So now I can, let me see, view logs, okay, CloudWatch logs, management, there's nothing here. I want to create an alarm. That's what I want to do, okay? I want to create an alarm. And it's not letting me create an alarm. I can do next, I have to select the metric. So metric, I have 607 metrics here. So I can choose per instance, but it doesn't let me move. It doesn't let me do anything. And I have 518 metrics here, right? So it doesn't let me see anything. If I select them, I see them here, but guys, I cannot do this. Not now, I don't have time for that. But this is the way you do it. I wanted to show it to you guys. Static threshold, anomaly detection, metric math expression. Okay, that's what you based your alarms are on. Specify namespace, metric, statistics, period, conditions, additional configuration actions. So you can have an average, and then the 5 minutes, condition static, and then when the CPU is greater than, and then 100, okay? How can you have 100% greater than 100%? 100% is the top. Right? In this case, we put 80, for example, greater than 80%, and then you perform an action. Okay? So let's do an activity. If average utilization is greater than 50% for 5 minutes, correct. Okay, so that's a valid one, correct. Now this one, if the number of simultaneous connections is 10 for 1 minute, that's correct too. So those are valid, the valid policies here, or conditions. If the maximum bucket size is bytes is around 3.1, this is incorrect because there's no metric there, right? CPU is a metric. Connections is a metric for RDS, okay? If we take a look here at the metrics, let me come here to watch and say metrics, and then we look for all metrics, and then we look for, let me just select metrics, and then all, and then we get here RDS. Then we're gonna have per database metrics. Then we're gonna have CPU utilization. We're gonna have database connections, you see? But you don't have any bucket, in S3 bucket, you don't have that, the number of bytes. It doesn't make sense, right? So in S3, we have 12 metrics, right? We have bucket size bytes. Yeah, but here, if the maximum bucket size bytes is around 3, It's not around 3 for one day. It's not around 3. Okay, it's a fixed number, greater than 3 or less than 3, not around 3. That doesn't exist. Okay, so you can have the maximum bucket size. Have the bucket size here, right? But all the metrics they have to be a fixed number, and a greater than or less than, not around that. That doesn't exist. Okay, so that's incorrect because around is not a threshold option. You must specify a threshold of greater than or equal to, smaller, less than or equal to, or equal or less than. Okay, so greater than or equal to, less than or equal to, or less than. Okay? So if the number of healthy hosts is less than 5 for 10 minutes, that one is also correct. Okay, so that one, and maybe we can find it in the last load balancer, right? We can have some metrics there, and then we have the healthy host count, unhealthy host count. So those are metrics that we can find in the last load balancer. Okay, so right now, if we add it to search, right, add it to the graph, we said that we don't have any unhealthy host count. Okay, we don't have any unhealthy count.
Professor,
Yes, go ahead.
it's 7 p.m. Are we going to take a break?
Yes,
Or-
let's take a break. Sometimes I forget about that.
Okay.
All right, so guys, let's take a break, and let's meet back here at 7:10. Okay, do you have any questions before we go ahead and break? No questions?
No.
Okay, so I'll see you in 10 minutes. So guys, we continue. So if the volume of read operations is greater than 1,000 per 10 seconds, then that's correct. Okay, that's a correct metric. Okay. No, this one is correct. This one is incorrect. Incorrect. You must specify a statistic, for example, average volume, or things like that. Okay. If the average volume, not the volume. Now, so Amazon CloudWatch helps you monitor your AWS EC2 AWS resources and the application that you run on AWS in real time. So CloudWatch enables you to collect and track standard and custom metrics, set alarms to automatically send notification to SNS, or perform AWS EC2 auto scaling and Amazon EC2 instances. Define the rules that match changes in your AWS environment and route this event to targets for processing. Okay. So we have more and more logs here. Let's continue, and we say October 9. So everything is for today, right? Things that are happening inside your EC2 instance. And if we do ls again, and we do cat AWS logs, we have even more information. Okay, so guys, what I want to do is just delete that EC2 instance. Okay, and everything will be just gone. Okay, I want to terminate that EC2 instance. I want to terminate the elastic load balancer. Okay, so I want to look for the elastic load balancer, and that's going to be in the EC2 instance right here. I want to just delete the two elastic load balancers that I have here. Okay, I can delete them, and they're gone. All right. Now, auto scaling. Auto scaling. What is auto scaling? It's important to know what auto scaling does. Okay, so we have here some EC2 instances that you may need. In these EC2 instances, you may need more capacity, right? And this is not used. Okay, so you see here that Wednesday has a big usage here, and then on Thursday it has a smaller one, so that's unused capacity, right? Now with this, this is overcapacity. Okay, so that's the other end that we don't want. So this is what happens in on-premises, right? You may be under provision or over provision, and we don't want that. Okay, so what we want is this. This is what we want. So the green one is what is the use capacity, and what is provision is the gray one. Okay, so we have something that varies here based on the needs, and demand, and then that's how you can do this. Okay, that's the benefits of auto scaling. So it helps you maintain application availability, enables you to automatically add or remove EC2 instances according to conditions that you define. You detect, just give me 1 second, guys. Sorry about that, guys. Okay. So we were saying that it helps you, enables you to automatically add or remove EC2 instances according to conditions that you define. Detects, impaired EC2 instances and unhealthy applications and replaces the instances without your intervention. So this is auto scaling, automatic. That's why it's called auto scaling, right? And it provides several scaling options: manual, schedule, dynamic, or in demand, or predictive. Okay, those are some of the policies that you can have there to make auto scaling work. Okay, so typically weekly, this is a typical weekly traffic at Amazon.com. So it's very steady, right? We see that there's a pattern that is followed here, right? This is when you have the regular, regular seasons, like there's no events or a special holiday or anything. What happens every week in on Amazon. So this one, it's a little more, more remarkable because this is a traffic to Amazon in November. So we have the challenges to efficiently guess the unknown quantity of how much compute capacity you need. Okay, so you may have 76%, here that is not used, right? And you have 24%. But the good thing about this auto scaling, because Amazon has auto scaling, Amazon works with AWS, right? I'm talking about Amazon.com, okay? And of course, the same company, but different names, right? One is for selling books and buying books, selling all the stuff, digital goods and assets and things like that. And the other one is for renting a platform for companies to be able to bring and migrate their resources to the cloud. Okay. So auto scaling plays a major role here because, when you have a steady traffic like this, at 25%, but then starts growing. But it's hard to know when that's going to happen. In the case of Amazon, they can predict it because, for example, next week, I think is the 13th of October, it's called Prime Day. And they know that day they're going to have a lot of sales. Okay. Now, auto scaling groups, you can create an auto scaling group. It's a collection of EC2 instances that are treated as a logical grouping for the purpose of automatic scaling and management. And of course, every single instance that you create with auto scaling, they're going to be exactly the same. Okay. You have a minimum capacity, a desired capacity, and also you have a maximum capacity. So launch or terminate instances are as needed. So the instances that you don't need, then this guy is going to delete them. Okay. Now let me show you something here. Okay. Let me create, first of all, let me create a launch configuration. Okay. So I'm going to create a launch. I have 3 here that I'm going to delete. Okay. Okay. This is the first step for auto scaling. You have to create the skeleton of the EC2 instance. Okay. So it's going my launch configuration. Okay, I'm going to choose the AMI. I'm going to choose Ubuntu CentOS. I'm going to choose my image because it's just a snapshot that I took before. I'm going to choose the instance type. Let me choose here. Let me see T2 micro. Okay. Which is the one included in the free tier, right? I'm not going to choose any instance. Well, I can choose the role that I created before, this guy here, if I want to install the CloudWatch and all of that, CloudWatch agent. Okay, so I can put it here in what it says user data. Okay, Here, I can put that guy that I did before, okay? The CloudWatch agent, right? I can put it here, okay? But I'm not gonna do that. So I'm gonna just do my image. I'm gonna choose that. It's not gonna be spot instances. I don't want that, okay? The role, I'm not gonna use any role, okay? Okay. Uh, then I'm going to, I don't want to have detailed monitoring. That's gonna cost me money. I don't want to have EBS optimized instance. No, not now. The root is gonna be the same for every single instance. I'm going to use probably select an 61. I'm gonna choose probably this port 80, right? And they give you a suggestion here, do not use 0.0.0/0. That's not recommended, okay? But for the sake of this, I'm gonna use proceed with the key, okay? And I'm gonna choose this key, okay? And I will be able to SSH to every single instance, okay? I launched the configuration, now it's done. I'm now going to create an auto scaling group, okay? Which is going to take that skeleton that I just created, right? And use it to create the EC2 instances, my auto scaling group, okay? And now I'm going to choose the launch configuration here. I'm gonna choose my launch configuration here. And that's gonna give me all this information that I need, that I already have, the AMI, the T2 micro, the security group, the key pair name. It doesn't give it to me, but I know what it is. And today's date when it was created. This is GMT, okay? Now I just choose the VPC, it's gonna be the default one. I can have several subnets here, as many as I want. I have 6 in the North Virginia region, so I can choose all of them, right? And then I can do next. I can enable that load balancing. I don't want that, okay? This is the health check test period between the time between performing the first health check and the other ones. Okay. Enable group metrics collection within CloudWatch. I can do that too. Okay, we'll do that. Then the site capacity, minimum capacity is going to be 2. The site capacity is going to be 4. And maximum capacity is 6. Okay. So now I can have a target training policy, right? I can say when the average UP utilization is 80, right? 80, for example. Maybe this is the warm up between when the time when is in the creation process. Maybe let's say 60 seconds. Disable scaling. I don't want to disable that just in case he has to. Yes. Enable instant scaling protection. I don't want to do that. And then I'm going to do next. Maybe I want to add a notification. So I can do this when something is launched, an EC2 instance is launched, terminated, failed to launch, failed to terminate. It's going to send me an email. I can do next. And then you can add tags. Okay. So I can say probably, I can say web servers, probably name. sorry, web server. Okay. Right. And then I can do next. And this is going to be the summary of whatever I'm doing. Right. And then as soon as I hit that, it's going to create 4, because that is site capacity, right? It's going to create 4 instances exactly the same, right? So let's wait for this to, to be creating these instances. So I can see here the instance management center. So it's already in, they're healthy, and their life cycle is pending right now. So they're pending. If I come here to the EC2 console and I take a look at this guy, I see that 3 have been created and 1 is in pending. Okay, so you can see they're exactly the same. The work position in different availability zones, because that's what I chose, right? And now I have 4 instances running. Now, guys, I'm gonna do something here. I want to stop 1 or stop 2. I'm gonna stop 2, and then let's see what happens. Okay, I'm gonna stop 2 instances, and let's see what happens. So we come back here, and we see that 1 instance is not there anymore, okay? Because it's considered unhealthy, right? And if we refresh this, we see that 1 is shutting down and the other 1 is stopping, okay? Right? Stopped, okay? So now I can come here and it will immediately try to meet the requirements. That is 4, 4 instances. Okay, so this one is terminated. Let me terminate this guy. Okay, this one is terminated, right? Now, if I can check my email, right? My email. I just got a notification here that my instances were stopped. So it's auto scaling test notification for group auto scale. It says that another one is a termination of auto scaling group. This termination of group, the auto scaling group message, account ID, description, terminated instances. So I'm getting this information, which is a little messy here, right? Now, right now, what's going on is launching a new EC2 instance. You see here, is launching EC2 instance, terminating that one. And I'm gonna see that right now, if I take a look at my auto scaling group, I see that the design capacity is 4. So I can come here, it says instance management, and then I have 4 again. So that's the good thing about this. If 1 instance, is stopped or have any problem, then auto scaling immediately is going to create another 2 for me to meet this desired capacity that I established when I created the auto scaling group, which is very good, right? It's amazing. And then I can create these instances exactly the same. If I install an Apache server, all of them are gonna have an Apache server. If I install the CloudWatch agent, all of them are gonna have the CloudWatch agent. So whatever I install in the launch configuration, that's what's gonna happen for every single EC2 instance that auto scaling creates for me, okay, which is real cool. Okay, we have another one here, launching EC2 instance. Beautiful. Huh? Does it happen on premises? It doesn't. On premises, you have to be guessing what's going to happen. Okay. And we continue. Where am I? Okay, good. So this is what happens. This is where I adjust it, right? Scales out, launch your instances, scaling, you terminate an instance, okay? Now we have this guy here, how Amazon S2 instance autoscaling works. Well, guys, you know how it works already. So what, we have an AMI, EC2 instance, launch configuration. That's what I did. AMI, instance type, role, if I need a role, security groups, EVS volumes, right? Autoscaling group, that's the first step, launch configuration. Autoscaling group, you can create a VPC, some nets, you can create a load balancer, and then when maintaining the current number, health checks, right? This is where it happens. Manual scaling, minimum max desired capacity. Schedule scaling, schedule actions. Scaling policies, dynamic scaling. Predictive scaling, auto scaling. So all of this you can do with auto scaling. All of these things. Okay? So if you come here, right? Activity here. You see everything that has happened since I created this. Automatic scaling, we have all these policies here. You can add a policy, right? You can have a policy here. I already have one, okay? I already have one, right? This is the one that I created, right? When the CPU is as required to maintain average CPU to 80, right? Take an action, auto remove capacity is required, right? So we can add a schedule this, okay? So we do this, for example, create my schedule policy. Decide capacity, I can say 4, 5, 3, 8. Once every 1 day, every week, starting when? October, today is the 9th, 12th, until October 16th. And then the end time is going to be 12. Right? Now, this is a cron job, as you can see here, on Monday, right? At minute 0, hour 0, everything on Monday. Okay? Every month, every day, Monday, to create that. And then I have a schedule action here, right? You can add a policy, and the policy can be a step scaling, step scaling, like different steps, what to add. So I can have here my step scaling policy. So choose an alarm clock. I don't have any alarm clock right now, but I can choose. This is all for DynamoDB. I don't have anything for this, so I can choose one, create an alarm watch, but I couldn't create one when I was there. So maybe you can add one capacity unit, right? Okay. And instances need seconds to warm up, 60 seconds, right? And this is to add one EC2 instance, right? And then an alarm, right? I don't have an alarm here. I have to choose one, but this is not for EC2 instances, so I don't have anything for EC2 instances. If I have something like greater than 80%, then I can put this, and then I can add what EC2 instance, and then that's the way it should be, right? So that'll be a step policy. So I have to right now. I have a schedule one. I can create another one and I can do a simple scaling, right? But I don't have a CloudWatch alarm, so that's the problem here. Okay, with this guys, you can program and do whatever you want with auto scaling, and it's gonna be beautiful. Okay, it's gonna be beautiful. Let me stop the auto scaling because I don't want to create any of this anymore. Okay, so I'm gonna stop this guy, and it will delete. Well, it will not delete the instances, so we have to just come here and terminate the instances, right? And then do this, and then eliminate those instances here. Now it's shutting down. I don't have to worry about that anymore. So we can do all that, guys. Implement the dynamic scaling. You have elastic load balancing, elastic auto scaling group, utilization, CPU utilization, and then CloudWatch will tell you what's going on, because CloudWatch is the one that has the metrics, right? CloudWatch is the one that indicates when the CPU is high, right? So your average CPU utilization is 60% for 5 minutes, greater than 60% for 5 minutes. So create another EC2 instance so that you can cope with this traffic, right? So that will be executed, and then the auto scaling will do that, right? And elastic load balance will be notified of that, right? And then, the traffic will start again, send the traffic to that instances, whatever instances. So that's how it works, okay? So again, CloudWatch has the alarm, okay? You create the policy. Now, when that happens, auto scaling will be notified, because CloudWatch notifies auto scaling. Then auto scaling will notify, we create the instances, right? And notified elastic load balancer, and elastic load balancer will start sending traffic to those instances, okay? So auto scaling monitors your application and automatically adjusts capacity to maintain steady, predictable performance at the lowest possible cost. It provides a simple, powerful user interface that enables you to build scaling plans for resources, including EC2 instances and spot fleets. Guys, when you see the word fleet, that's a bunch of spot instances. That's what it means. So an Amazon EC2 instance fleet, it's a bunch of, it's like saying a group, but they call it a fleet, okay? Amazon Elastic Container Service, auto scaling also works with this guy. Amazon DynamoDB tables and indexes, and Amazon Aurora replicas. All these guys will be also affected by policies by auto scaling, okay, as well. Now the takeaways here: scaling enables you to respond quickly to changes in resource needs. Amazon EC2 auto scaling maintains application availability by auto scaling, by automatically adding or removing EC2 instances, right? An auto scaling group is a collection of EC2 instances. A launch configuration is an instance configuration template. Dynamic scaling uses Amazon EC2 auto scaling, CloudWatch, and elastic load balancing. And AWS auto scaling is a separate service from Amazon EC2 auto scaling. Okay. So 2 different auto scalings. That's the one that RDS uses. That's the one that Amazon DynamoDB uses. But this guy is for EC2 auto scaling. That's just specifically for EC2 instances. So lab 6 is going to be scale and load your balances, balance your architecture. Okay, guys, all the labs are open. I hope you're doing them. Okay, because remember that that's going to help you for your exam. If you can visualize your platform, your AWS platform with services already created, that's going to help you a lot. Okay.
When does the access to the lab how long after this class is over?
I have no idea.
A week? A day?
I have no idea. So probably today is the last day. I'm not
the
sure.
Labs?
Yeah, I'm not sure. Guys. AWS is the one that sets that time, not me. The exams are gonna be open until next Friday. The exams, my exams, the ones that you're receiving.
Yeah.
I'm not sure about which labs. Guys, have you been using which labs
Not yet.
for the exams? How about the rest of the class? Are you using which labs?
I will.
Yes, I am.
Yeah, that's good. That's good. I mean, which labs is highly recommended. Highly recommended. I recommend which labs really highly. Okay. Okay. So this is the scenario. You have You have this architecture, 2 availability zones, 1 internet gateway, 2 public subnets, 1 and 2, with the CIDR 10.0.0.0/24. We have a NAT gateway here in the public subnet here. We have a web server here in the public subnet 2 with a security group. That web server is accessing this RDS, right? Which is the primary database. Then we have an RDS that is a secondary one that is being replicated synchronously. Okay. These 2 RDSs are in private subnet 1 and 2. They have a CIDR of 10.0.1.024 and 10.0.3.0/24. So now, the final product, what you have to do is create an Amazon machine AMI from a running instance. Create an application load balancer, create a launch configuration and auto-scaling group, automatically scale new instances with a private subnet, and create Amazon CloudWatch alarms and monitor performance of your infrastructure. So guys, basically what I did, except the CloudWatch alarm, which I couldn't create due to the space in the screen. Okay. The final product, this is going to be the final product of your lab. It's going to be exactly the same here, except that now you have an application load balancer that has a security group, and that is going to be, sending the traffic to this web instance right here in a private subnet, and this web instance right here in a private subnet, and then here we're going to see the internet facing, security group, RDS primary, and see this. Now, auto scaling is going to be in the middle here, auto scaling these guys here, because this is where the instances are. Okay. Now we have something here. Okay. So this at first sight, this application load balancer looks like an internal Elastic load balancer, but it's not. This guy is communicating with the internet gateway. Okay. Now you may have an internet facing Elastic load balancer here, and you may have another one here, which is an internal load balancer that only communicates with the private subnets. Okay. This is pretty uncommon to see a web instance in a private subnet, but that's possible as well, because they have an Elastic load balancer that is there, right? Is there sending the traffic to the web instances. Okay. Now, guys, in these guys, remember when we create an Elastic load balance, an EC2 instance, we in the security group, we put 0.0.0/4/0. So in this case, we have to put the security group of the Elastic load balancer. That is the one that is sending here. Because remember, when we create security groups, we're just allowing traffic into the EC2 instances. So you have some rules, okay? You have some rules. And let me do something here real quick. What time is it?
10:45.
7:46, okay, good. Let me create real quick. Let me create an EC2 instance here. Okay, just this. See here. Add key. Okay. And this. Okay. So I'm creating an instance here. I'm gonna go ahead now and create an Elastic load balancer. And then I'm going to create an application load balancer. Okay. So I'm going to say that this guy is internet facing. Okay, good. I'm going to do this. I'm gonna put this in. Okay, in this one. Let's see. Okay. Then that's what I did. Two subnets. Yeah, you want to make it more highly available. That's okay. I can do this. Okay. Give it a name. My app ELB. And then I can just go and create the security group. And this one, let me create the port 81, just use that one. And I'm gonna name it, let me give it a port 80. Okay, port 80. Okay, port 80. Okay, that's fine. Now let me just create a target group. Okay, a target group, new target group, and then the instance. Let me continue here. Let me register this guy. Okay, add to register. Good. And now I'm going to create the last load balancer. Okay. Now, this is going to be the point of entry, correct? So it's provisioning right now. Okay. Now, what I have to do is come to the instance, right? And right now, this instance has monitor networking security, has the launch, this one. Okay. So what I can do is just add a custom TCP, and then here I can say this is going to be the security group that's going to come into this instance. Remember that we choose here what traffic we allowed. So I'm going to allow this one here, and then port is going to be probably port 80. Okay. And then I'm going to allow this guy to come to the EC2 instance. Okay. So whenever someone tries to access my account, right, it's going to be through this guy. No one can access my account. So if someone tries to access my account through port 80, no one will be able to do it, because the only rule that I have for inbound traffic is whatever traffic is coming from the last load balancer. So my only point of entry from my elastic,
I'm done.
from my EC2 is my elastic load balancer. Right? That's a single point of entry. So everyone has to come through this guy. Okay. So if I have here an Apache server installed in this EC2 instance, I can come here, and in my elastic load balancer, I can grab the DNS right here and put it here. Of course, I don't have anything installed now. It's going to hang there and timeout. It doesn't back gateway because there's nothing there, right? But if I try to access my computer from the internet, I won't be able to do it, because the only accepted traffic is from the elastic load balancer. Okay, so that's how you connect your elastic load balancer with your EC2 instances, right? So guys, today, in summary, we did this module and we learned how to indicate how to distribute traffic across Amazon EC2 Cloud, Compute Cloud EC2 instances using elastic load balancing, identify how Amazon CloudWatch enables you to monitor AWS resource and applications in real time, and explain how Amazon EC2 auto-scaling launches and releases servers in response to workload changes, perform scaling and load balancing tasks to improve an architecture. Okay. So guys, I have a question for you here. Which service would you use to send alerts based on Amazon CloudWatch alarms?
SNS.
SNS.
Okay.
Full notification service.
And that's exactly what I used with my auto scaling. I got the emails, remember? I got the emails. All right, guys, that was it for this lesson today, right? Have you taken the knowledge check?
I'm about to do it. If they close, I want to make sure I do that.
I did.
Guys, it's very important that you do this, guys. It's very important that you do this. You know, that's super important. And guys, your exam is this weekend. Okay. So please, please do all this, catch up, you know, and try to, you know, study for the exam, right? Now, I'm gonna create here. And by the way, what do you think about the practice exams? What do you think about it?
Was a wake up call.
Yes, it was a wake-up call.
It's a wake-up call, right? And believe me, guys, the practice exams is not an indicator of the exam. It's super easy compared to the exam. You know, I never took the practice exam because I took the exam when I did the cloud practitioner.